So welcome to this webinar session about Python scripting with Terrasolid applications. In this session, I will introduce how you can utilize Terrasolid tool capabilities in MicroStation Python scripts. I'm Antti Järvenpää. I represent Terrasolid, which is a software company. And as you have found your way to this session, you probably have some idea what we do and what kind of products we have, but mainly tools for point cloud processing and imagery processing. And you have probably also heard my voice before, so I work in technical support and I have done some training sessions past years. Briefly, some practicalities of this session and about the agenda. So this is going to be a webinar type of session where I will explain and present and show how things can be done and what's available, and show a couple examples. About the agenda, so I will briefly first talk about scripting in general, what it can be used for, and then about the Python and especially about MicroStation Python, which is a relatively new tool made available in 2024 version of MicroStation. And starting from the release, there have been certain tools from Terrasolid package available to access through that Python scripting interface. Actually, our tools ship with two different interfaces for implementing scripts with the Python. And in this session, I will present examples of both of those alternatives. And then in the end, I will wrap up the session. So we'll briefly check how one can get started with creating your own scripts. And I will highlight some key notes of the session to remember. So first, about the scripting in general. So overall, the scripting of different tools is for advanced users, and it can be for special use cases like research and development, where the aim is to expand the workflows, where the existing tools are utilized in new ways, and maybe new tools are being built on top of the existing ones. It can be used to streamline, so make something currently adopted in use to work in a more seamless way for the tasks we are using the tools for. And it can be used, as I mentioned, for expanding existing tools or also integrating different tools into seamless package. And some reasons for the scripting might be save work time, making the processes more seamless, mitigate the faults done during the processes. So if there is some tasks requiring conventionally a lot of interaction with the software, but basically the process is repetitive, so we might do the same sequence of button presses over and over. We can script the sequence and utilize the work from the package, so to say. And also we might be able to produce more value with our work if we manage to integrate different tools in one package. So that was a brief introduction into scripting, and now I will talk about the Python in MicroStation environment. So overall, Python is a programming language, and the strength of Python is often considered to be the wide availability of different frameworks libraries, possibilities to expand the existing tools, and the simplicity programming language offers simple to use tools and capabilities, and still it can expand to many use scenarios. And like I mentioned, Bentley MicroStation version 2024 introduced the Python available as a scripting language in their software package. So in the user interface, this version has added the Python manager to the user interface for creating, running, managing Python scripts. And that packages also the MicroStation capabilities and publishes those for the use with the Python language. And this is MicroStation feature, so it runs on top of the MicroStation platform. So from our portfolio, the things I will show in this presentation, those are available when running Terrasolid tools on top of MicroStation platform and not on Spadix platform. And for the complete information on which packages are available or in which packages of the Bentley CAD systems the Python is available, verify the availability from Bentley. So at the moment, the MicroStation makes the Python available, but for example, OpenCity's map overview doesn't offer the Python. So I quickly show on my own screen how it looks like. So I have MicroStation 2024 installed, and when I pick in the user interface the Utilities tab in the ribbon, I have the Python manager over there. And when I open it, it opens a dialog which shows the scripts I have. Bentley provides a good number of generic examples how to use the MicroStation's capabilities with the scripting interface. So these are some ready-made examples that are shipped with the installation of the MicroStation CAD tools. Then I have some of my own scripts here below. So I could edit the scripts or run the scripts. But before I will come back to my presentation and talk about the tools that are available from Terrasolid package for this Python scripts. From Terrasolid tools, like I mentioned, there are two different ways to utilize the software capabilities with the scripts, with the Python scripts. And there is the scripting API that was released a couple years back, and we have a webinar recording available describing the capabilities of that scripting API. I recommend you to check that for more or for the detailed information about this scripting API. And then there are public functions. So from the package, there are some functions made available for use for C++, but we can access those functions with Python as well. And the main difference between these two is how we can utilize the features or how these two behave. So this scripting API, it's relatively similar, or it's close to controlling the software through the user interface. So it's close to the using the software through the buttons, toolboxes, dialogues that are available in the software. This is more a one-way communication. So the scripts can give commands through this scripting API, and it will execute something in the software, but the software can't respond to the scripting API. It won't return some values. Then the public functions, those are some functions that are available in the software. Those are documented in header files shipped with the software installation package. And using those functions, we can directly give instructions for the application core. So we are operating on a lower level with the application. And in general or overall, these two different interfaces can be mixed. So one script could communicate with the software using both of these alternatives. These are not exclusive, but we can mix these two alternatives. And some information, documentation about the public functions is available in the software setup path, and their folder include has a couple files which describe these available functions. So for example, if I open the public functions.h, it lists a good number of available tools, capabilities, and documents the expected parameters and the return values. So if we compare these two side by side, the scripting API, it is designed for MicroStation scripts, originally for Visual Basic, and now it can be used in the same way with Python scripts. And then the public functions, those are for add-on programs. So Terrasolid tools can be expanded by developing own add-on applications, or there could be some other application built on top of MicroStation, which could also call these public functions, but also our Python scripts can utilize these same capabilities. And the scripting API is similar to the user interface or the common usage when we press buttons in the software, while the other connects closer to the lower level of the application. For the scripting API, the commands that are available and the settings we can check using a logging. And like I showed for the public functions, we can see the available tools in the setup or installation folders, installation packages. Through the scripting API, as it's close to the usage through the buttons, it's like commanding the application, while with the public functions we are more discussing with the application because we can receive some feedback as the return values from executing a function. So with scripting API, the common use case could probably be some workflow automatization. We can run some workflow pressing single button when we have prepared it into a script. And then with public functions can do the same, but we could also embed something our own to the software. So we can access the loaded data, manipulate the data, and implement this way our own tools on top of the software using the simple scripts. And then I will show some examples how this is done in practice. And first I will demonstrate the utilization of this scripting API. For more detailed presentation, I recommend to check that webinar which we have had in the past. It is available through our website about the scripting API. Arttu Soininen, who is our main developer, he held the presentation a couple years ago, and now I will briefly demonstrate some example. So to develop a script utilizing the scripting API, we first need to know the commands and the settings we want to use. And those we can check using logging. So I opened the keying window and then type in keying command scan log dialogs and the file path where I want to store the commands. So now the application has started logging the button presses, tool activations, actions I use after the start of the logging. So now, for example, I may want to automate the software so that every time when I load in the points, I want to display two windows side by side. So the same point cloud in view number 1 and maybe view number 2. And I want to make the views synchronized, and I want to display the points in certain way. So apply certain display mode setup for both views. So now to log, I will run through my preferred workflow. I open the display mode dialog. I want to view the view number 1 using color. And I want to view the points in view number 1 so that I have only ground points enabled, and I want to display the shaded surface in the area. Maybe I'm doing some ground classification in the area and I want this setup for checking the ground. And in addition, I want to make the views synchronized. So when I move the view number 1, the view number 2 follows. So I open the synchronize views and make the view number 1 and view number 2 match each other. So this is the simple workflow I want to write into a script. So now, after I have done the steps, I open the keying dialog and I repeat scan log dialogues to stop the logging. And then I open the text file that the logging produced. So I have here now visible the commands given to the software. So I have opened the display mode dialog. I have applied some settings, and then these were the settings I had visible in the display mode dialog when I closed the dialog. And then for synchronized views, these are the settings I applied when I closed the dialog. And now to build this into a script, I have an example ready-made to save some time during our presentation. I have it here in the examples. So I have there synchronized views. With the Python manager, we can use the Bentley's or the MicroStation's built-in Python editor or our preferred text editor. Let's check first how it looks in the MicroStation's built-in editor. Yes. So a script might look like this. In the beginning, I import some MicroStation Python libraries. This hicat input queue command or function and its method send command is required to give for the CAD environment, CAD interface, the commands I want to give for the scripting API. So I repeat this and list there the commands I want to give for the scripting API. So if we check the log file, now actually in my example script, I don't apply the display mode settings, but there I specify the synchronized views settings. So to include the display mode part, I could add there more rows and include there the display mode settings, scan set, and the setting name and the value, and then in the end scan action view display mode, and then it would set the display mode settings in the script. But I will not go into too small details of using this scripting API in this example, but I recommend you getting the details of the API usage from that recording which we have. And in the end of the script, I include scan end script, which clears the queue of the unassigned commands and variables for the safety reasons. So if I would have poorly written script, then this command in the end ensures that nothing is left for upcoming execution of the tools, not to mess up with some commands. And now we could test this script. So first of all, I disable the view synchronization. So now the views are not synchronized anymore. And then from the Python manager or the Python editor, both have the run Python file button. I press the button and MicroStation Python runs through the script, runs the commands, and it opened the synchronize views dialog, set the settings, and now the views are synchronized again. Okay, so that was a small example of the usage of the scripting API. And then I will proceed to usage of the public functions. So this is the additional or alternative way for giving commands to the software. This gives us deeper capabilities and a bit different approach. And depending on the use case, we should select which one we use. And of course, we can also mix commands or capabilities of the two different alternatives. So in this example, I have prepared a small reporting tool for checking the distance attribute histogram of the points. I will go back to MicroStation. And then I have here in my examples this distance histogram Python file. And if we check the points with a bit different display mode, I change the view number 2 to show the points using distance attribute. The distances are representing the height from the ground level at the moment. So from this point cloud, the ground has been classified, and then for 4 points, the distance to the ground level represented by the ground points has been computed. Let's check the example now using a separate text editor. I have here a Visual Studio Code. In this example, I'm using the public functions. So the public functions are available from the DLL, from the application. So if we check the setup directory, Terra64, MA, you have there, if you have installed the MicroStation version of the software, you have there these different DLL files like terrascan.dll, from where I'm now utilizing functions in this example. And the different other DLLs also have their public functions that can be utilized, and all those are documented in the include directory files. And for utilizing this, so like mentioned, these are for C++ applications designed for those. So not native for Python, but using C-types library, we can connect our Python code to this and utilize these functionalities in the Python code. So in the beginning, I binned these public functions. So basically, I define in my code the function names I want to use and define what are the parameter argument formats. So what these functions require as input and what those will return. So then Python can interpret the information that is being sent from the public functions to the functions and from the functions back to the script. And maybe I show the example in practice so you get better idea what it does. I select the script and then I run the script using the button. And in my example, I have implemented a small reporting tool showing the histogram of the distance values. And now from this figure, we can see that most of the points have a distance value close to 0. And this is very much normal situation because most of the points are captured from close by the ground level. So maybe I want to select classes. So I want to pick another class to display in the diagram. And now this select classes dialog is one of the available public functions. So my Python script gave command for the terrascan to open a select classes dialog, and then when I do my choice, hit OK, terrascan gives for my script the list of selected classes. And now my small script application updates the diagram to show only the selected class. And this is now from ranges from 25 centimeters to 2 meters, which has been probably my distance value interval for the classification of the medium vegetation class. And all these examples will be included in terrascan setup package. So in next or following release, you will be able to download the examples, and those will be added to the Terra64 and example folder. So then you can check, for example, the synchronize views.python file in there. And additional thing for these public functions, or special thing, is that we can access the loaded data. So so far we have been reading the data. So the application has been checking the values of the distance attributes and displayed the histogram of the values on the screen. But in addition, we can also manipulate the values. So if I show a bigger dialog and I change the dialog to show a little less stuff to make it more clear. So now I have there the distance column representing the distance values. And in this example, I have the setting for changing the bin width, so how wide are the bars in the graph. And there is additionally buttons for manipulating the distance values. So if I press the plus button, the distance values will increase. So now I have set the bin width to 25 centimeters, and when I press the button, the values increase. Now, yes, it increases only for the medium vegetation class. So I will change the class selection to demonstrate this. So I hit the plus button and you see the distance values increasing, and of course the display also changes. Here we see the values changing. And checking that briefly, it works in a way that terrascan can give us the location where the information is stored. So the return value is type, or it gives us the pointer. So it tells the location where the distance information is stored during the program execution, and then in the code we may manipulate the distance values. So there the bin width is added to the values, but it will be easier to check this when you have this example available in your own computer. So those were two brief examples, and now brief wrap up or to-do list, how to get started, how you can test this on your own. So as said, this requires a recent enough Bentley MicroStation platform, and then Terrasolid tools running on top of that platform. And then in the interface, using this Python manager, you can open the list of Bentley example scripts, and there you can also create a new script and test it, see how it works. Bentley has documentation for their part. So from the web, by searching from Google, you can find MicroStation Python. And then for the Terrasolid tools, you can check the logs and the webinar about the scripting API. And from the include folder, you can check the public function documentation. Yeah, so here I have actually listed the same sources of information I just spoke out loud. And to wrap up the session, so using this scripting, we can expand and speed up our tasks. It is not something that we should start with, but it is something which we can use when we are confident with the tools and we want to achieve something more. And the strength of Python is that we have many libraries. There is a huge number of examples available, and it's relatively simple to use. Doesn't require too much typing of the variables. And from Terrasolid tools perspective, we have two different alternatives with two different level of access to the software capabilities. So I thank you for your interest, and hopefully this was helpful for you, and we see, for example, in upcoming Terrasolid event in Vilnius, and now I will check the questions. If you have some, please send those, and I will check the unanswered questions.